So what we're looking for to combine resistors, we had this idea that series resistors, R sub S is the sum of the resistors, and parallel resistors, we had the 1 over Rp is the sum of 1 over R n in parallel. And what we need to, the rule we need to apply is that if something's in series, what's the same for all the resistors in series? Current, all right? So the same current. And things that are in parallel have same voltage, because those are the only two things we know about. So they must be the two answers. All right, so to make sure something has the same current, we can follow along the resistors wherever they're going. And if we get to the node where they're joined together, we say, is there a third or fourth or any more than two things? Is there anywhere else for the current to go? So when we get to this corner, we go through this 8K, for example, to this 4K. At this corner, there's nowhere else for the current to go. It has to keep going from the 8K to the 4K, or if it were flowing the other way, it would go from the 4K through the 8K. The only place for the current to go, so we would say those two have the same current, so they're in series. So we would say 8 plus 4 is 12K. All right. And then it would be customary to redraw the circuit. 12 volts, 2K, 6K. And now we need to put a 12K resistor in place of the 8 plus 4. So the rule there is if we're going to replace them, we need to look at the nodes, all right? And we need to hook up to the same nodes that we started at. So I'm going to go back to my labels up there, A, B. Now node C we're getting rid of because we're combining those two. So my same nodes over here, A, B, and D at the bottom, I'm getting rid of C. My new 12K is going to go between B and D. So I would draw it over here, 12 kiloohms, and it connects to B at the top and D at the bottom. So I've connected it back in the same spot from the same, across the same node pair. Then I would look at the 6 and 12, and they don't have the same current because the current's going to maybe enter this node from the 2K resistor and split. All right, so it looks a little bit more like a single node pair circuit over here. So 6 and 12 are in parallel. They have the same voltage between node B and node D. And there's no other nodes in the middle to branch out of. So then I'm going to combine those. So I would have 1 over Rp is 1 over 6K plus 1 over 12K. All right, with two things in parallel, that's where the shortcut formula is convenient. And the shortcut for two things is the product over the sum. So 6K times 12K over 6K plus 12K. So we're going to have 72 over 18. Does that simplify it all? Thank you. Of course. I knew it did. I just blanked out looking at it. OK, 4 kiloohms. All right, so then we put that in the same spot between nodes B and D. So now we have 12 volts, 2K. I've still got node A over here, and B at the corner, and D at the bottom. 2K, and now this is 4K. So then those are in series, so I have 6K. So the one current here is going to be 12 over 6K, or 2 milliamps.